Hi everybody, so in this video we are going to talk about normalization. So normalization is a method of organizing data elements into tables so that you can reduce the data redundancy and data duplicacy. There are four major reasons to why we normalize the database. First is to avoid the duplicacy of the data. And the second one is insertion, to avoid insertion anomaly, deletion anomaly, and update anomaly. And in this video, we are going to focus on these three kind of anomalies. So let's just get started with the first one, that is insertion anomaly. And for that, I'd like to pull up my Excel spreadsheet so that we can pull up an example of a database and then talk about each of these anomalies. So let's say that we have a table, student table, where we are aiming, or where the objective is to store the student information and the department where that student is currently enrolled in. So remember, in this table, the student table, we have the student ID and the department ID, the department name, the department chair name, and also the name of the full name of the student and also the age of the student. So right now this table has the information of both the student and the department. So now let's make a hypothetical situation or hypothetical circumstance that the university decided to introduce a new department. Let's call it department ID 3. The department name is called Information System, and the department head is, let's say, UV for now. So presuming that this is a table where the main objective is to insert the information of the student, but right now what we have in hand is that we have a new department and that department information needs to be inserted into the table. And right now we don't have a separate department table. We have only one table which stores the information of both the student as well as the department. So now that given that we want to insert the information of this new department, information systems, but because this is a new department, it does not really have any student enrolled into it yet. So when we try to insert the information system department information into this table, we are going to run into an error. And the reason why we're going to run into an error is because for this table, student ID is the primary key. Department ID is not the primary key. So because in this case student ID is the primary key or the primary identifier for this table, when we try to insert the information of this newly introduced department in the university, we are going to run into an error, and that's exactly what we call the insertion anomaly. So that was our insertion anomaly. I'm going to delete this one, and then so that we can focus on the next anomaly type, that is the deletion anomaly. So I'm going to copy paste this table and I'm going to bring it here. So now let's say that student ID with the student ID 2 decided to drop the university, and again our context here is the same. There is one table, the student table. The table name is student, and in the student table we are still storing the information of both the student as well as the department. So given the situation where the student T decided to drop from the university, we are going to have to run the deletion query so that the student ID 2 information gets deleted. And when we run the query delete student where student ID equals to 2, when we run that query, we are going to end up getting rid or delete we are going to end up with deletion of row 2 or the ID 2, and in that case we are also going to lose the information of the electrical engineering department, and that is something that we may not want because we would still like to preserve the department ID information, right? Because the student may have dropped, but the department is still there, and we would still like to keep this information regardless of whether a student decides to drop the university or not. So this kind of situations where we might end up deleting the information of another entity just because we are getting rid, or just because we are deleting a row from a row from a table because the student dropped or the employee quit. So in those kind of situations where we might end up losing the information of the department or of an entity just because we needed to delete an information from another table, that is what we call the deletion anomaly. So now let's talk about the update anomaly. For this case, again, I'm just going to copy paste this table because if we can stick to the same example, I think it's going to make more sense. So I'm going to copy paste example, and then I'm going to add some additional rows. Let's say the student name is DE, and then GT. Let's give example 33. Department ID is again 12. And I'm just going to copy paste this information over here as well. So our example over here is still the same. We're still using the same student table where the information of both the student and the department information is being stored. So now let's say that the department chair for the electrical engineering department has changed. So previously it was ST, but now let's say the department chair is RD. Okay. And now, since there has been a change in the department chair for the electrical engineering department, we would like to update this table where the department name and department chair information is being stored to RD. So in this case over here, the example that we have, it only has 4 rows, so we could just go ahead and then change the department chair name to RD, but that's not how it works in the large corporate organizations. In the large organizations, there are going to be several student whose, or the several rows where where the row which has the electrical engineering information stored, that corresponding row may need to be changed to RD. And so when we are doing that, there might be cases, or there might be instances that one row may get updated but the other row may not get updated, and that's what we call the update anomaly. The situations where one row may get updated but the other row may not get updated, that is what we call the update anomaly. And all these anomalies, that is the insertion anomaly, deletion anomaly, and the update anomaly, all of these anomalies can be resolved by this concept of normalization, because the idea with the normalization is that for every entity they should have a separate table. For example, in this case over here, this example that we have where we are storing the information of both the student and the department in the same table, if we could break down this table to 2 different tables, one table just to store the information of the student ID and another table just to store the information of department ID, that perhaps makes more sense, because if we are ever to update the information of a department, let's say if this department chair information, we could just go to department ID, department table, and just update that information. And likewise, if a student drops or joins the university, then that information can just be updated to the student table. So that's the concept of normalization. That is, how do we make sure that the data in the table is organized? And that is the concept of normalization. So coming back to where we started this video from, so the primary reasons why we normalize a table is that so that we don't run into the issues of insertion anomaly, deletion anomaly, and the update anomaly.